now we are finding the direction of the acceleration of the ink drop, and we know that there is force upward and the charge is negative so far, but mass is always positive, right? Cannot be negative. So it's from F is equal to ma. Since mass is always positive, whatever the direction of the force is, the acceleration should be the same. So it's same as force, which is upward as well. So it's accelerating along the positive y direction. Okay, so now we will do a checkpoint question after learning a few things. So those are kind of the steps. I hope you see now how this is done. So let me just go back to that first. In the beginning we said we have F is equal to QE, so we can relate the force and electric field thing about the sign of the charge. And then we have force and acceleration. Now we know that they're related and we can use it. The charge can have mass, and then we can use this Newton's second law to relate force and acceleration. And after that, the last step is relating it to the position. So this is where we left. And we will do the checkpoint question number 3 from the textbook. In the figure, what is the direction of the electrostatic force on the electron due to the external field shown? So external field, again, this is shown that way, but they highlight this area. That really means that there is electric field in this region everywhere. It's to the right, same magnitude. It is because it is uniform, okay? And in which, so first of all, we are finding the direction of the electrostatic force on the electron. So that's important. So this is a negative charge. And let's do that first. Since the electric field is to the right, and again, F is equal to QE, and you have, and your Q is electron, so you would write it as negative E, because E is this E is elementary charge, and which has a magnitude of 1.6 times 10 to the negative 19 coulombs, and it is negative because this is electron, right? So when you put that in, you can see that those vectors are opposite each other, and that's why it's going to be opposite force. So it will go to the left. And for part B, in which direction will the electron accelerates if it is moving parallel to the y-axis before it encounters the external field? So now we are going to think about F is equal to ma. And here, again, since mass is always positive, it has to be the same direction as the force. So the acceleration, since force is to the left, acceleration should be to the left as well, right? Let's just take some notes. Part A is left, part B is also left. And if instead the electron is initially moving rightward, will its speed increase, decrease, or remain constant? So which one would happen? If it was initially moving rightward, so before it started entering here, let's say it was moving with the speed to the right, and then it entered this electric field region. It feels a force which is to the left, right? It's kind of being pushed away from this region. So that means it's going to slow down, right? Because velocity and acceleration direction, so just focus on these two for now. Acceleration is to the left, velocity is to the right. Remember, when they don't match from physics 160, we know that it means it is slowing down, it's decreasing its speed, right? So now we can use what we learned in mechanics and apply it to these concepts as well. And this question is now, again, we were going to put everything together, and we're going to solve this as an example.